Okay, now for Lab 4, you are also not going to be required to know a lot of calculations. You need to be familiar with some of the terms like solubility, saturated, etc. And you do need to understand that the basics of the solubility product constant. And understand that solids do not go into calculating your your solubility constant. So here there are definitions for solubility product constant, um, and for sparingly soluble salts. Um, so for example, for sparingly soluble salts, the solubility will be a very small value which is decreased significantly by the presence of common ions. So let's go on and do a... Oh, and you also need to understand that if you're not using a common ion, you will not be seeing the common ion effect. So let's go ahead and do a practice problem for Lab 4. So how will adding a common ion affect the following variables? So let's go over some of these variables. The first one is the solubility of a sparingly soluble salt. So if we remember going back into our lab manual to our sparingly soluble salt section, the solubility will be a very small value which is decreased significantly by the presence of common ions. So in this case, our sparingly soluble salt, whatever it be, let's just say we have, actually I think they have a good one in the lab. Yeah, here we go. So let's use this silver acetate solution. So this is going to give us our silver ion and our acetate. Now, how will the addition of a common ion, such as silver, affect this reaction? So if we add a little bit of silver, how will this affect the solubility of a sparingly soluble salt? So just as the lab manual says, it will decrease the solubility of that salt. So for these sparingly soluble salts, this ion will essentially be competing for the solubility in water. So they are already very, very lightly soluble in water. So they will, with an extra common ion, they will become even less soluble in water. Okay, so that answers our first question. Now for the second part, how will it affect the solubility product constant? Now remember by definition that the solubility product constant is a constant. So it's not going to change regardless of if you change the concentration. Yes, this constant is typically equal to the concentration of one ion times the concentration of the other. However, you will not need to worry about or you will not be able to change the constant. It will just determine how much of each one of these ions you will have. And finally, the last question is, how would it affect this reaction? So the way I like to think of these is kind of as a balance. So here we have the reaction which was silver plus chlorine becomes silver chloride. So what happens if we add a common ion? So we're essentially going to be increasing the amount of silver. Now in order to balance this, if we think of this as a little balance, if we increase the amount on this side, so now we have more weight on that side, the balance is going to tip down to here, unless we put some weight on this side. So what you're essentially going to have to do is whatever you do to one side, you also have to do to the other side. So since we had an increase in the silver on this side, we need an increase in the silver chloride on this side. And that is pretty much the common ion effect, and all you really need to know for lab 4 or 5. Alright, this brings us to lab 5.